Hello everyone. Welcome back to another session of our Cardiac In-Service Education program, Know the Heart of ICU. So far we have completed Unit 1 and 2 chapters in Unit 1. In the Chapter 1, you have seen normal ECGs, and in Chapter 2, you had seen all the dysarrhythmias. And now you know that the dysarrhythmias can be categorized based on the origin of the impulse. If the impulse is originated from SA0, it's sinus dysarrhythmias. You can have sinus brady, sinus tachy, and sinus arrhythmia on top of the normal sinus rhythm. If the impulse is originated from atria, you can have a premature atrial contraction or complex, PAC. You can have a atrial tachycardia, regular atrial tachycardia, multifocal atrial tachycardia, or paroxysmal atrial tachycardia. And you can have your atrial flutter or atrial fibrillation. If the origin of the impulse is from junction, there comes your premature junctional complex, your junctional rhythm, or sometimes with the normal rate we call it as accelerated junctional rhythm, and you have your junctional tachycardia. So it may be a normal junctional tachycardia, or it can be an AVNRT, AV nodal reentry tachycardia. And if the impulse is originated from the ventricle, the classical sign of your broad Bissayer QRS complex. And if that's the case, you have your premature ventricular complex or PVC, you have your ventricular tachycardia. If there is no pulse, that's a cardiac arrest scenario, and you have your ventricular fibrillation, always cardiac arrest scenario, and you have your idioventricular rhythm. That means very slow agonal rhythm originated from the ventricle. So these are the usual dysarrhythmias you find in the clinical setting. Today, what you're going to do is kind of a practical session how to recognize an ECG or ECG rhythm. So the first thing we are going to see this rhythm. Look at the P waves first. Are they P waves? Yes. And it's a nice smooth P wave? Yes. So it is originating, most probably it is originating from the sinus. And after the P wave, do you have the total PR interval less than 200 milliseconds? Yes, the PR interval, that's the interval from the beginning of P wave till the beginning of QRS complex. So that's your PR interval. So the PR interval is less than 5 mm or 200 milliseconds. So there is no AV blocks. And do you have QRS complex after every single P wave? Yes, here we have QRS complex after every single P wave. That means this rhythm originated from your SA0, and the QRS complex is narrow. That's one of the characteristics. So your impulse is originated from SA0. Then what else you have to check? You have to check, is it regular? Yes, you can see that it's regular. So, and you check the rate. Is the rate normal? Yes, the rate is normal. So this is a normal sinus rhythm because impulse is from SA0 and the rate is normal and the rhythm is normal. So it's a normal sinus rhythm. But what happens if the rate is less than 60? So here also you have your P wave, you have your normal PR interval, and you have a narrow QRS complex follows every single P wave. But the only problem here, it's very slow. The rate is only 54, less than 60. So it's from the sinus and it's regular, but the rate is low. So that is called as your sinus bradycardia. So when you see this rhythm, when you look at this rhythm, you have your P wave, you have normal QRS, normal PR interval, less than 200 milliseconds or 0.2 seconds or 5 mm, and you have QRS complex for every single P wave. You have QRS complex. That means it's a sinus rhythm. Is it regular? Yes, it is regular. It looks very regular to me. And what's the rate? The rate is tachy, like it's 138. So it's sinus and it's regular and it's tachycardia. So we call it as sinus tachycardia. And look at this rhythm. What's the difference? Do we have P wave here? Yes, we have P wave. And is the PR interval normal or prolonged? PR interval is normal, less than 5 mm. And do you have a QRS complex after every single P wave? Yes, we have QRS complex after every single P wave. And what's the problem here? The problem here is it's irregular. The rate is normal and it's from sinus, but you can see that it's irregular. See the interval between two R waves and see the interval between two R waves here. So that means it's irregular but sinus. Irregular sinus rhythms are called as your sinus arrhythmia. So this is how we recognize the major rhythms. So you look at this rhythm now. See, you have P wave, normal PR interval, you have QRS complex, yeah, you have P wave, normal QR interval, your PR interval, and you have your QRS complex. But see this little baby here, he should not be there, because after your T wave, there should be a TP interval before a next P wave should originate, and that interval should be constant for a regular normal sinus rhythm. But here you see, before the normal SA node impulse, there is a premature impulse came here. The normal SA node impulse after the T wave, after a TP interval, then the normal SA node impulse. So after the T wave, the normal SA node impulse should be somewhere here, but a premature impulse originator here, but we don't know for somewhere. So definitely this rhythm is sinus rhythm with a premature complex, but we don't know, is this premature complex originated from atria or junction or ventricle. Is a premature complex narrow? Yes. So it's not from ventricle. You will not find any narrow complex originated from ventricle. So it's not a PVC. Now you are ended up with two options, either PJC, that means your premature junctional complex, or premature atrial complex. Look at the P wave. Is there any P wave? Yes, there is P wave. And is it upright? Yes, it is upright. So it's not junctional. In junctional complexes, you will not find any P wave, or in case you find a P wave, that may be before or after QRS, but that will be inverted in shape, because impulse is originated at the atrium, at the AV node, and it going upwards. The normal impulse flow is from SA node to downwards, but if the impulse is originated from the AV node, impulse move upwards to atria and downwards to ventricle. So what happens here? You have an upright P wave. That's a premature P wave. So it's not junctional. So it's definitely from atria. So what's there now? Premature atrial contractions. So after a premature beat, you can see the compensatory pause. Little longer it would take, because why it's happening? The next P wave supposed to be here, but it wouldn't happen because there's a premature complex. So there's a narrow QRR interval. And SA node will be silent at this stage. It won't produce an impulse because there is already a depolarization is happening in the ventricle. And SA node will be fire at the next regular interval. That's why you have a longer RR interval, a shorter RR interval followed by a longer RR interval. That's a classic sign of a premature atrial complex, any premature complexes. So that is called as your compensatory pause. So that's your PAC. Now you know how to recognize your PAC. And you see here, easiest rhythm to identify. No discernible P wave, and it's very irregular. You can see that. See the RR interval, this much, low, this much. It's all changing. RR interval is changed every single beat. Blindly you can say that it's a AFib, atrial, because it's narrow, so it's not VT, and there is no discernible P wave, so it's an atrial fibrillation. And look at this rhythm. You have P wave? Yeah, you have plenty of P waves. And is there any specific nature of the P wave that attracts your attention? Yes, it looks like a saw. It looks like a wood saw. You have seen the saw. Yeah, that saw-toothed P wave. That's a classic symptom for your flutter. We don't call that even a P wave. Instead, we call it as a flutter wave, F wave, because that's not a normal P wave. That's a flutter wave. So we use, in advanced practitioners, use flutter waves instead of P waves. Okay, so it's a 3:1 atrial flutter. That means for every 3 P waves, you have a QRS complex. It's a regular atrial flutter. We call it as atrial flutter with 3:1 conduction. That means after every 3 P waves, you have a QRS complex. That's why it's called as 3:1 conduction. It can be 1:1, it can be 2:1, it can be 3:1, it can be 4:1. It can be even varying conduction. So atrial flutter of a varying conduction, we will call it. Okay, so this is an atrial flutter. And when we go to the other rhythms, when you go to the junctional rhythm, see, look at this rhythm. Okay, you have a P wave here and a normal PR interval, and you have a QRS complex, and P waves are there. It's normal, regular sinus rhythm until this body comes in. It is normal, regular sinus rhythm until this body comes in. See, look at the intervals between your RR interval, intervals between your R waves. You can see that this is a narrow interval, so this is a premature beat. And where is this premature beat comes from? Look for P wave. There is no P wave. There is an inverted P wave after QRS. You look closely. I'm doing it as a live, so I'm actually looking at the rhythm as you are doing so. So you can see that a small tiny inverted P wave after QRS. So it's a low nodal junctional complex, or in simple terms we'll call as a junctional complex. So there is a premature complex originated from AV node. So it's a premature junctional complex. It's a normal sinus rhythm with premature junctional complex. So it's easy to identify. And look at this rhythm. Is there any P wave? No P wave. If there is no P wave, what's the next wave? QRS complex. Is the QRS complex narrow or broad? Wide, beside. It's narrow. So it's not a ventricular rhythm. So definitely this rhythm is from AV node. If the rhythm from sinus, definitely there will be P wave and PR interval. If the rhythm is from atria, definitely there will be a P wave or a flutter wave or kind of a fibrillatory waves. But there is no P wave at all. There is nothing in the atrial side, you can see. That means this is a junctional complex. If it was wide Bézier complex, it would have been a ventricular complex. But it's narrow complex, so it's a junctional complex. Sorry, it's a junctional complex. And you see the rate. This rate is normal for AV node. The normal SA node rate is 60 to 100, 60 to 99. But a normal AV node rate is somewhere between 35 to 45, 50 in that range. So it's kind of a normal rate for the junction. So we call it as a junctional rhythm, because the rhythm originates from the AV node and that follows the normal AV node rate. So it's not a junctional bradycardia. We call it as a junctional rhythm. Junctional rhythm is a bradycardia because it's less than 60, but it's not a junctional bradycardia. It's a bradycardia, but it is junctional rhythm. And if you look at this, do you have a P wave there? Look closely. Yes, you have a P wave there. See the P wave? Little and a small P wave which is inverted before the QRS complex. So it's a junctional rhythm. If the rhythm is atrial or sinus, P wave will be upright. If the rhythm is junctional, P wave, there may not be any P wave. If there is P wave, it may be after or before QRS and it would be inverted. So it is a junctional rhythm. If this one was a broad QRS, you can even suspect ventricular rhythm, but there is no broad QRS here. It's narrow QRS complex. So if it is narrow QRS complex, ventricular rhythm is, we are literally eliminating that from the options. The three options: junctional, atrial, or SA nodal. Inverted P wave, so definitely it's a junctional. But the rhythm, normal rate, the rate is normal. Normal junctional rate is around 40s, 35 to 50, but here the rate is around 82. So it's an accelerated junctional rhythm. Because we cannot call it as a tachycardia because it's not 100 or above. It's not a junctional tachycardia. It's junctional rhythm, but it's an accelerated rate because normal junctional rate is very low. It's an accelerated junctional rhythm we call. And you see this one? Can you see a P wave? No. You cannot see a P wave here. And there is a QRS complex. And you may think that it's wide QRS complex, but if you look at the graph, it is less than, it's almost 3 mm. If to classify for a wide QRS complex, it should be more than 3 mm or 0.12 milliseconds. So it's classified as narrow complex, maybe with a little bit of bundle aberrancy. That's why you can see a little notch in the QRS complex, but it's not a bundle branch block. This little notch in the QRS complex, definitely a bundle branch block. You will learn it in the next unit. So it is a narrow QRS complex still within the parameters, and there is no P wave. So it's not atrial, it's not sinus, just because there is no P waves. And it's not ventricular because it's not a Bézier, wide Bézier complex. So what is it then? It's junctional. So it's a junctional rhythm, but what kind of rhythm? What's the rate? It's tachycardia. It's not junctional rhythm. It's not accelerated junctional rhythm. Instead, it is more than 100. So it's a tachycardia. And when you have your AV and RT, it follows the same patterns as well. And the difference between junctional tachy and AV and RT is actually the physiological mechanism that caused the rhythm. Is it the junction firing faster, or the impulse is taking a loop within the re-entry phenomena is happening within the junctional AV node? That's the only difference between two. But in a clinical scenario, both looks the same and both needs the same treatment. So in clinical scenario, doesn't make much difference. Okay, so that's your junctional rhythms. And when it comes to your PVC, you can see that, yes, see there is a normal P wave, QRST, normal P wave, QRST. Before the normal P wave and QRST occurs, you can see a wide Bézier complex, wide Bézier QRS complex and an inverted T wave, totally Bézier complex. It's not narrow, so it's not AV nodal, it's not junctional, it's not atrial, it's not sinus, because it's wide Bézier complex. It's classical sign of a ventricular complex. So it's a premature complex, and this premature complex originates from the ventricle, so we can call it as a premature ventricular complex. And you see this one, your agonal rhythm, your just before your asystole, the patient usually go into this and then go to the agonal rhythm. Your idioventricular rhythm, it's called as, because there is no P wave, there is no narrow QRS complex. So that means this rhythm is originated from the ventricle. It's a wide Bézier complex, so it's originated from the ventricle, but it has a normal kind of a rhythm, and the rate is very low, 36. So that's a classical rate for a ventricular rhythm. So it's a normal, it's kind of ventricular rhythm. Your SA node is not firing, SA node stopped working completely. Then if the SA node is not working, usually your atria or your junction should take over. Your atrial impulse sites are silent, no one is firing an impulse. Then your junction to take over, but your junction, your AV node is silent. It's like dead, it's not working at all. So to save life, as a last sign, what our ventricle do? Ventricle will act as, one of the ventricular focal area will act as a impulse generator. Like your SA node, the area in the ventricle start to work as an impulse generator. That's a speciality of the myocardial cells or the heart. Every point in the heart, either the SA node or any part of the atria or the junction, that's the AV node or ventricle, can produce an impulse. Okay, and that impulse usually whichever source has higher rate will sustain. But in this case, SA node is silent, your atria is silent, your AV node is silent, so ventricle had to take over the role of an impulse generator or a pacemaker. So ventricle but can produce the rate in a slower manner. So it's a ventricular rhythm and it's an idioventricular rhythm. If the ventricular rhythm goes in a normal rate, we cannot call this as a ventricular tachycardia because it's not a tachycardia. So it's an accelerated ventricular rhythm. But if it goes as a tachycardia, if it goes more than 100, we call it as a ventricular tachycardia. And you have your final kind of rhythm, that's your ventricular fibrillation. So it's a fibrillatory waves only. So this is how we are actually recognizing the rhythm. It's an easy job if you practice. It's an easy job. Only thing you need to remember, how will you identify the source of an impulse? How will you distinguish between SA nodal impulses, your atrial impulses, your AV nodal impulses, and your ventricular impulses? For your SA nodal impulse, you have a smooth curved P wave and you have a PR interval and narrow QRS complex follows. If an atrial impulse, there will be P wave, but it's at some kind of abnormal shape based on which atria, left or right atria, producing the impulse. And if it is, and it's easy to identify the atrial flutter, sawtoothed, and atrial fibrillation, no discernible P wave. And if it's from the AV node, there may not be any P wave at all, but the QRS will be narrow. If there is P wave, it will be inverted, and it may be before the QRS or after the QRS, but it will be inverted based on high nodal, mid nodal, or low nodal rhythms. And if it is ventricular origin, blindly you can say wide, bizarre, complex, it's ventricular. So it's an easy job, but you need to practice. So practice makes perfect. We had a principal, our nursing college had the a psychiatric nurse as one of our principals in the first couple of years, first 1 or 2 years, and he used to say that his native language is Kannada. It's an South Indian language, and he used to say that, Baba, practice makes perfect. Okay, so everyone, I hope everyone will practice and everyone will be perfect in rhythm analysis. So good luck with that. And the next unit, we will start with AV blocks and bundle branch blocks. In 2 different units, you will learn AV blocks and bundle branch blocks. Good luck.